All right, our last video will cover layers, communication, and factors. I meant to put layers in the last video, but hit stop and figured we'll just put it all in this one. So let's talk layers. We've already been working through them. Here's a bit more information about the aesthetic mappings and the geometric objects. So for aesthetic mappings, you've seen that we've gone over color, size, alpha, and shape. There's also a bunch more. So I've hyperlinked in here a source with other things that you can play with your aesthetic mappings. And then when it comes to our, let me move myself here, get my slides working. There we go. Geometric objects, you can plot the same data with different geometries. So here I've been using both scatter plots and lines of best fit. You can also split them up. So if you'd rather just have a line of best fit or a scatter plot, that's totally okay too. You can display those different aesthetics in different layers like we've talked about with global versus local levels. And you can also use facets. So facet wrap, those are subplots that display one subset of the data based on a categorical variable. And our last example, that variable was islands. So we were able to show flipper and another numerical variable alongside penguin species and island. And then facet grid is a bit more advanced with a combination of two variables. So here in facet grid, your arguments will be rows followed by a tilde followed by the column name, and you can adjust your scales using the scales equal arg. Now, your bars are going to stack automatically if you're using a bar chart with multiple variables, but you can adjust those. You can play with those settings. So position equals fill, as we've already seen, makes those bars equal height, but position equals dodge also puts those bars next to each other. So here we have two variables, and then we have different classes of vehicles. You can either have them, stacked like this, stacked to 100% with more of a proportion, or next to each other. It's really your choice. Scatter plots too, you can add in geom jitter, which adds a little bit of randomness, which can be really useful at large scale. It might look confusing when it's tiny, but when it's bigger, it's easier to see patterns when it's jittered like this as opposed to having straight lines. So let's look at our code for that. Here, I'm going to do R for Data Science section 9.2.1, exercise 1. And here we're asked to create a scatter plot with points that are pink filled in triangles. Here, same as usual, open up our data, say ggplot, give me these aesthetics. Aesthetics display will be, or displacement will be our x, highway will be our y. I'm using geom point because it's a scatter plot. I played around with shape. I decided that my color, which is the outline of the triangle, will be hot pink, and my fill will be pink, just to show you that there's lots of different colors you can use. I like to make the outline a little bit darker if I'm going to do this. It makes it easier to see. That's not a rule, that's just a preference. You can play around and find your own preference. I can also adjust the line type. So here, again, I'm specifying color as a global variable, and I can adjust that line type based on that global variable value. So here, DRV is drive type, four-wheel drive, front drive, there we go, or rear wheel, no, not even going to say it. It's just F4 and R for now. Those different drive types, now we can have different lines. So we've got dotted and dashed and just solid. And again, showing you how you can display different aesthetics in different layers. We're going to do something similar where we plot our x and y, displacement and highway miles per gallon, geom point, x and y. Then we're plotting a subset of our data. So now we're going to plot only those that are two-seaters, classed two-seater cars, classing those, or we're going to make those points red. And then we're also going to circle them. So we're adding in a separate layer of data here, and there we go. So again, these need labels. I clearly don't know my cars very well, but those are the basic mechanics where we've added in, here's our original X and Y data, and we've made these really, really stand out by making them red. Now for adjusting the bar chart, as I showed you, there's a few different ways. So note here in these examples, X is the same variable used both in X and color. So color is going to adjust the outline of your bars. So the fill will just automatically be gray or whatever your theme is set to. We'll get to that later. So it just made this a red, green, and blue outline. And this is set to fill, color. Now we're fill. Fill is where you want the bar to be fully that color. So now the bars themselves are red, green, and blue. Now we're going to fill aesthetic with something other than the variable that was used for X. So here what we have is that drive is both on the x-axis and also via color. We don't really need that. It's not telling us anything new. Drive is not a separate variable. If we want to do that, that's where we're doing our stacked bar charts or the different variation of it. So here, ggplot, miles per gallon, aesthetics, X is drive, fill will be class, and here we go. Here we go, where now those individual bars are broken down by the class of each vehicle type. If you want it to be everything is the same height and it's more of a proportion, position is going to be set to fill within the geom bar call, so position equals fill. And if you want those bars to be positioned next to each other, that's where we'll use dodge. So here you can see that they're side by side. All those graphs give us the same information, but different ways of displaying it, and you can decide what you think gets your message across the best. Same thing with scatter plot. Here we have our regular scatter plot. If you want to use the jitter argument instead, you just use geom_jitter, and it shows you something a little different. To me, it's a lot easier to try to see a trend from that second one versus this. This is very like mechanical, very straight. Here, it's easier for me to see more of a curved plot. So let's go back to communication. The whole goal of our graphs is we want to be communicating something about our data, right? That's the goal of graphing. And so when it comes to communication, a good graph is one that's self-explanatory. You don't want your audience to be spending lots of time trying to figure out what the heck it is that this graph is trying to say. And so to make your graph as self-explanatory as possible, of course you always want to have descriptions, you want to pull in the graph results into your overarching written analysis, but to make it so that your reader doesn't have to put a ton of extra work into interpreting your graph, you need to have labels, annotations, scales, themes, and layout. So our labels, we've talked about these. Your X and Y axes, you've seen me put those in via the labs argument. Your X and Y axes are always going to need units. Always, always, always. Is it millimeters? Is it miles? Is it hours? Whatever. I always want to see a unit attached because numbers without units don't really mean much. If there's a legend, so if you are plotting a categorical variable by color, shape, whatever, that variable name needs to be clear. So it can't just be what the column name is in your data. You might need to set it so that way it's explanatory. So rather than, like for the ESS5 data we're working with, there's a variable called sRound. Well, that doesn't mean anything to your audience unless you recode it to actually mean year. Your title should summarize the main finding, if at all possible. I was a little lazy with some of mine. I just showed what the variables were, but for your challenges, for your final project, anything that's meant to go out to an audience, you want that title to tell them what the main trend that you see is. The subtitle can point out exceptions or maybe add more detail, and your caption can point out where that data is from. And so I put here that I want you to recode your variable names and values to be explanatory before you visualize. That's just a step we've been working through with mutate and case-when and recode. That's really helpful when it comes to this final step of visualization. I don't want to see any zeros and ones in your graphs. So if you have, let's say, two categories, 0 and 1, don't give me 0 and 1. Tell me what 0 means and tell me what 1 means. You want it to be so that your audience member, in this case, in this class case, me and your TAs, but it could be in the future, this could be a report that goes to a nonprofit or something like that. You want it to be explanatory. So in this case, we have our title, fuel efficiently generally decreases with engine size. We have our subtitle that tells us about the exception, two-seaters, sports cars, are an exception because of their lightweight. We have our X and Y axes labeled, so engine displacement in liters, highway fuel economy in miles per gallon, And then I also have down here data from fueleconomy.gov. It's really helpful in your caption to explain where your data comes from. Same thing with our legend, it's very clear to me what car type means. So car type, okay, we've got two-seater, compact, and so forth. Annotations. So you can label your axes and your title, but you can also label within the graph. So in this case, you can label individual observations or groups of observations. So here, front-wheel drive, rear, I can't even say that, four-wheel drive. Geom text is going to be your function for this, and this is going to add in textual labels. There's a few other options, H-line and V-line, that have reference points. You'll see that in the very last example of my code at the very end of factors. Geom rect draws a rectangle around points of interest. Segment draws attention to a single point with an arrow. Now, I am not requiring that you use these. I think they're really helpful. They can make a graph better. It's not something I'm necessarily looking for. It's something that can add to your analysis, but if you feel overwhelmed, it's okay. I just want to see the basics. Scales. So you saw how RStudio and ggplot, it automatically puts scales on your X and Y axes, but you can adjust them manually. Let's say they're not what you want them to be. In your axes, you can control the position of your ticks and the labels. You've actually seen this in some example where I've asked you to work with decades. We've used the break function. In your legends, your labels can be adjusted. You can adjust the names. You can adjust for formatting like dollars or percentage or other things, and you can also change the legend location. Themes. So there's some basic themes that ggplot comes with that you can make your data fit. You can change it to be white background with grid lines or minimal theme with no background. It depends on you and your preferences. I encourage you to play around with these and find one that makes the most sense to you and kind of have your own personal style with what type of graphs you like to create. This is, again, not a requirement. It's just to make your graphs more legible. And you can also control the size, font, color, angle of text, as well as other things. And I point this out, you've actually already seen me use this. You've seen me use this argument in the hotel bookings example where I adjusted the text labels so that way they're not overlapping. Your layout. You can also place plots next to each other using the patchwork package. Again, I don't require that you do this. I just want you to know that it exists. So in this case, these aren't two separate copy and pastes. This is just one copy and paste that I did showing plot 1 and plot 2. And let's go to our code before coming back to our very last topic. So here, communication. It's so important when it comes to our graphs, just because a graph that isn't easily understandable doesn't really help you or your analysis. Again, in our labels, we've got units for our X and Y, we've got a legend description, we've got a summary of the main finding, we've got exceptions and other information in our subtitle, and a caption. Feel free to just copy and paste all of that into your own and adjust it based on your own data. And for our annotation, so there's a few ways we can think about doing this. My first stab was immediately to think, okay, let's already have our drive type mutated. So let's use case 1 like we've done in our past challenges, and let's mutate F to be front wheel and so forth. And then I just relocate drive type, my new variable, to the very front so that way I can see it. Great. So now drive type, rather than F, it's now front wheel drive. And so then we can try to plot it. So here, ggplot, MPG data, aesthetics, X is displacement, Y is highway miles per gallon, color is the different drive type. Geom point, I played with the transparency a little bit here just for fun. Geom smooth, line of best fit. And now Geom label repel. This makes sure that your labels don't overlap. X, again, we have our font being bold, and you can adjust different parameters for your font. And then I add no legend because we're going to annotate the data. But here we see a problem. Front wheel drive is in here a lot, and we actually only want one group to be labeled. So instead what we have to do is create a data frame with just that label information. So what we're going to do, create a new data frame called label info, open up our miles per gallon, group by that drive type, arrange in order of the displacement, slice, and then mutate. And then just select the variables we're interested in plotting. And here we go. Here they are. Now, with just that one instance of each, one instance of four-wheel, one instance of front and rear, now we can plot. So here, X, Y, color, geom point, all of this is the same except for when we get to that label section, we specify that our data that we're pulling from is label info. So you can plot more than one data set in one plot. Our aesthetics, X, again, these are all based on that label info data that we just created. And here we go. Now we just have one example of each. You can also adjust those labels to be percentage. So if our diamonds, we open diamonds, X is cut, fill is clarity. We're going to have two bar graphs because these are both categorical variables. We're going to have a bar graph with position equals fill. And then we're going to scale our y-axis to be different. So we're going to scale it to be continuous, and our argument name is percentage. Our labels will be the label of the percent. Here we go. Now we have percentage. You can do the same thing with money or other values. And of course, we can change the position of our legend. Let's say we don't want it on the right. It's automatically going to pop up on the right, but maybe we don't want it there. Maybe we want it on the bottom. Maybe it looks better that way. Here, this is all pretty similar to what you've seen, except for here, we're adjusting our legend position. So legend position equals bottom. There's a few different argument solutions that you can play with. And we're going to make this so that the legend itself has 2 rows of 4 columns. So you can specify how you want it broken down even further. And then of course we have our labels. So here we go. Rather than being on the right, our legend is now along the bottom, and we've specified that we want 2 rows with those 4 columns. And you can manually adjust the color scale. So here, we're going to use a presidential data set that's just inherent to ggplot. If you want to look it up, !presidential. We're going to mutate it to create a variable that tells what number the president was. It starts with 1 here, but it actually starts at Eisenhower, who's number 34, so we have to have 33 plus the row number. ggplot, we say, okay, great, we've created our ID column. I want to plot the start date with Y being the president number, color being the party. Geom point. Here you can actually create a segment in your graph. So you can have a line segment that starts at the end. It goes from the X date to the next ID. Scale, and here's where you can manually scale those colors. So Republican equals this very specific hex red value, and Democrat equals this very specific blue value. Now I've also added in titles and labs that weren't there in the example from the book. So here we can see, okay, you can also see kind of the lengths of the terms for each of these presidents, and it's a custom color format. In the book, it asks you to pick a theme and apply it to the last plot you've created. That's a section 11.5.1 exercise 1. Here when I look up theme, you can see there's so many different components that you can play around with. I mean, it would take hours to go through every one of them, so I won't. Just know that if it's something on a graph, you can likely change it with your theme. What we're going to do is the exact same code all here, except for we're going to try the Economist theme. So the Economist theme, automatically, this is what the Economist uses for their graphs, and they've put those parameters in this little package. There we go. So now it's this theme. You can do a minimal theme. You can do whatever type of theme that you want. Now exercise 2 in this section asks you to make your axes labels blue and bold. I went a little bit further just to show you the different ways that you can play with this. So these are all familiar. This is what the code that you see above. But what I've done with theme is I've made everything a different shade of blue because I felt chaotic in the moment, and that's what I wanted to do. So I've said for the axis title, I want the color to be this deep sky blue and bold and italic with Arial font. The y-axis should be cyan with bold, and same thing, like I've adjusted it. Now, generally when you're graphing, you want everything to be consistent. This is just for an example to see that you really can play around a lot with this. Made things bold, made it italic, made it different shades. So if you're writing a report and you know that there's a color scheme for that report, you can request those values and pull that into your graph. This is a tip for if you're making posters or something like that. A really, really nice touch can be to match the color scheme of your graph to the rest of the poster. If you want to know more color options, I've linked it right here. You can click on that and you can read all the different like named colors. So I used hot pink and red and cyan blue and all of those things. Now let's say you want to put plots next to each other. You can also assign plots to an object name just like we have with data frames and variables and all those other things. I can say plot1 or P1 is equivalent to just this very basic plotting the miles per gallon data, displacement versus the miles per gallons as we've been doing. Geom point, very simple. For the purpose of the example, I'm not adding any more. So we have P1, P2, P3, all the exact same thing. And let's say that I want those all together. I just want to copy and paste it once. I want it to be a single figure. Here, using the patchwork package, what I've done is I say that P1 and P3 are next to each other in the top row, and that P2 is below them in the second row. So here we see this, and you can play around with that. Now let's go back to factors, which is the last topic for this week. And I put factors in this week because they're really helpful when we think about bar charts specifically and just graphing in general when you are working with categorical data. So ForCats is our tidyverse package that works with categorical data. Just a reminder, I've talked about factors since the very first lecture, but factors are categorical variables that have a fixed and known set of possible values. So education levels or something like that, it's fixed and it's known, there's only particular levels. You can use the FCT function, fact, to automatically compute levels if they're not already supplied or if you don't feel like typing them out. So before, I've used a different way to create a factor. Here's yet another way. You can use FCT. And there's a few different things that you can do when visualizing factors. You can modify their order using factor reorder. That's only going to be non-ordinal data. So if the different levels, it doesn't make sense. If it doesn't matter if one's in front of the other. That doesn't make sense for something like education level, where a bachelor's clearly becomes before a master's, clearly becomes before a PhD, and so forth. You can move a factor to the beginning. So let's say, I don't know, or NA or something is a value, you can move that just to be at the very front. You can modify your factor levels, you can recode them, and you can collapse different factors into smaller units. So that you can collapse them into smaller numbers of categories. And let's look at our code to wrap us up for this week. Again, there's not an example just because there's about nearly 500 lines, over 500 lines of code for this lecture, so I didn't want to add yet another example at you. Let's look at factors. So again, FCT, this is a function where you can create a factor. It goes through how to use it there. If I want to look at GSS-CAT, that's the data set that's used in this chapter of the textbook. GSS-CAT is just a sample of the categorical variables from the General Social Survey, which you've used in a past challenge. Using section 16.3.1, exercise 2, it asks you to look at the most common religious and party ID identifiers in the survey. So here I just do a quick check of the variable type. I see that both of these are in fact factors, so religious and then party ID, they're both factors. I do count, and there we go. I have a count of the different religious categories in this data. I see that Protestant by far comes out top. Same thing for party ID, we can do that. And we see independent by far, not quite as far as Protestant, but still ahead, comes out top. Exercise 3 in this section asks, which religion does denomination apply to? And you can find out with either a visual or a table. For a visual, what I've chosen to do is I say, okay, let's open the GSS-CAT data set. ggplot, our X is going to be our denomination, our color will represent religion, and so will our fill. Using the fill position in geombar, it has to be a bar graph because these are both factors, they're both categorical. I adjust the text, so here's an explicit line. If your text is overlapping, here's how you can adjust it. Axis text X equals element text, and you can play around with the different angles. I've done 90 because my labels are pretty long and I just don't want them to run on top of each other. And then I've used my colorblind scale. I'm a pretty big fan of that one. Great. I mean, this is really, really ugly, but at first glance, what we can see is, wow, this is very Protestant. By far, denomination mostly applies to Protestant because we see just a sea of this like light magenta-ish pink. The same thing if we were to find out with a table. Great. We see that our biggest category by far is, again, Protestant being represented here. And like, for example, not applicable is what we see with Catholic, or not applicable with Jewish, whereas with Protestant we see lots. But we see the Protestant is like overwhelmingly dominant, but we see there's like a lot of different categories over here, and not all of them super make sense. So you can play with collapsing them into smaller levels. So our first is using factor lump n by specifying a number of levels. So we're lumping these categories together. We can do this so that there's only 10 categories. So we've got Protestant, Catholic, Nun, Christian, other, Jewish, Buddhism, and so forth. If we did the same thing for the denomination, if we use factor lump low frequency, we see that we got a bunch of categories, and that seems a little bit excessive. So you can specify again here on denomination. I specified only 10, so I get not applicable, other, none, and then Southern Baptist, Baptist, don't know which, United Methodist, Episcopal, yeah, there we go, and so forth. Now you can also modify your factor order when it comes to graphing. So here we're going to create a new data frame called religious summary. We're going to group by religion and then summarize TV hours and the count of TV observation. So here we just create a data frame, religious summary, great, the religion, the TV hours, and the count. We're going to plot, just basic religious summary, that data frame that we just created. X is TV, Y is religion, here, geom point, but I don't see a particular trend. It's super scattered. But it makes sense that we can actually reorder these based on TV numbers because these are factors. So what we can do, and what I'm doing a few extra steps here. First, I've decided that I want to add in an average line. So I'm calculating the average hours watched. And I also want to see what religions are above average in the amount of hours of TV consumed. That's for later, but those are just some steps I've taken. So average numbers, I just take the mean. Above average, those TV hours that I filter out. I filter to only keep the religions where the TV hours is greater than that average. And now let's come to plot. So this is kind of the biggest, this is our last plot for this lecture for this week, and this kind of pulls in everything together. So here, what we're doing is we're calling ggplot. We're saying, okay, let's use that religious summary data. Our aesthetics, X will be our TV hours, just like it is here. Y is going to be the reordering of religion and TV hours. So it's reordering religion based on the TV hours, and the size of the dots, here we have the scatterplot dots, the size is going to be n, or their count. And then we're going to use geom point, because again there's this numerical value. I added in a vertical line at the intercept at which it's the mean value that I calculated earlier. So I say geom v line at the x-intercept of the average number of hours. I say it's going to be red, and then I decide that it's a dashed line just to make it a little less overwhelming. I have our labels, so hours per day watching TV, and X is that hours per day, Y is religious affiliation. I have a caption, data is from gss.dataexplorer, and I found that by using the question mark. Our title, religious affiliation and hours spent watching TV. Subtitle, those who don't know, Native Americans and Protestants watch above average. And then size on the label will be, on our legend label will be number of participants. I'm also adding in a label. So here, let me move myself quickly. Label here for my annotation. I'm going to say geom equals label. I played around with the X and Y position, and you'll see when I plot it what that means. The label, I just type out the average is 2.98 hours based on the mean that I calculated. I played with the text size so that it made sense. And then I've also I've created circles around the data that is above average. So I've done a subset of the data. I've used that above average data to add in yet another layer. My color is red, my shape is an open circle, and then I don't want to show the legend for this because the legend, I just want to be the regular black circle. So you can play around, take out this show legend argument and see what it does. It took me a little bit to figure that out. But here's kind of a combination of all of these different things that we've learned about. Let me move myself again. So we see we have our title. We can see that the above averages are circled in red. I have my mean marked, and then I label it. So that label doesn't look as good on Zoom as it did here. Let me move this out, but you can just play. You can play around the X. I guessed it around 3.5-ish is where I started. I ended up placing it at 3.75. You can make it bigger, you can make it smaller, but here we see the numerical value, the categorical value. We use the scatter plot that also shows the number of participants, and that's our conclusion to visualization.